So now we have done the first reaction, which is reduction. We call it as Raymond. Okay. Next, we're going to have electrophilic addition. Okay. So the additions of unsymmetrical alkene follows Markonikov Rule. We will need to understand what is the meaning of unsymmetrical alkene. Back to the story above. Okay. This structure is known as unsymmetrical alkene. Why we call it as unsymmetrical alkene? Because if I chop this part, chop the double bond part, the carbon on the left hand side and the right hand side is different. So that is unsymmetrical alkene. Okay, or the what do you call that, environment at the left and right is different, so that's unsymmetrical alkene. But for this case, right, if I chop this part, left and right is the same, so I call this as the symmetrical alkene. Okay, same go to this. This is also symmetrical alkenes. All right, you all take down first. Now, recall back the total number of electrophilic addition. It branched out to 3. That means there will be 3 electrophilic addition, and all of them follow the general rules known as Markonikov Rule. So now we're going to study the Markonikov Rule, which apply to only the unsymmetrical alkene. So according to the Markonikov Rule, it says that in an electrophilic additions to an alkene, the more positive reagent, for example, the hydrogen ions, should be added to the double bond carbon that has a greater number of hydrogen atoms bonded to it. So, for example, okay, now I'm going to show you this. This is the alkene that I have. The double bond is here, and I add with HCl. So I will need to identify around my double bonded carbon what is the number of hydrogen atoms that's bonded to it. So for this carbon, I only have 2. For this carbon, I have 1. I'm not going to care about this 3 because this 3 hydrogen is not directly bonded to this carbon. I only care about the double bond carbons. Okay, how many H will bond to the double bond carbon? So this one has 2, this one has 1. Okay, that's it. So next, I need to identify which one is more positive. The H is more positive. So the more positive H will be added to the carbon that has more hydrogen. So the structure looks like that. Okay, I'm going to show the original structure first. So this is what you have, right? Without showing the double. So now if I add the H will be added here first. Okay, because this side has 2H, just like this. Then the Cl will be added here. If let's say everything followed the rule, I'm going to call this as a major product because it follows the rule. It follows the Markonikov Rule. But there is also another product form where it doesn't follow the Markonikov Rule, it goes against the rule. Okay, instead of the H moving to this side, it moved to this side. Okay, so in this manner, we call it as a minor product. Okay, and this is anti-Markonikov rules. Okay, so listen to this thing first. Okay, then you try on. Now, when we have a skeletal formula like this, we also need to highlight the double bond. So because this is the only position that's reacting, and this is a hidden H. Okay, we will always need to show the hidden H only at the C double bond C. I repeat again, we only need to show the hidden H at the C double bond C. The rest of it, all the hidden H here, we don't need to show because the H is not going to attack this and this bond. Okay, now So where will the H go? The H can only have two positions to go. One is this spot, the other one is this spot. So we will need to see which spot having the greater number of hydrogen. So this carbon, is there any H? No, because this is a C, this is a C. So no H, but this carbon has only one H. So the more positive H will move to the greater number of hydrogen site, so which is here. The Br will be bonded to here. Understand? So that means we are not going to touch the original structure. We only redraw the structure without the double bond that looks like that. Up to you, understand? Huh? So we are not going to put the double bond first. So now you think again. The H should be added here. Means I do not need to put anything here because it's hidden H already. It becomes a hidden H. So the Br I said should be here, right? So make sure your bond starting from here. Like that. Because some students will show me things like this. That's wrong. Because this carbon, which is this carbon, doesn't drag. It only involves this carbon and this carbon. So you cannot put your Br over there. Okay, so it should be branching out from the carbon that is reacting. Like this. So if it follows the rule, we call it as a major product. And if it is minor product, it doesn't follow the rule, so it attached over here. You can see the hidden H is still here. This H is still hidden here, but I don't draw it up. Okay? You can copy and try the last questions.
Yep.
Okay. The H, okay? The H will be added to which side? Again, we focus on the double bond. There's a hidden H here. The H will be added to the more hydrogen side, which is this side. But the OH will be added to this one. Okay? Again, the carbon involved is just this carbon and this carbon. Do not add to any of the carbon. So therefore, it will be like this. This is a major product. And that the minor product will be like this. Okay? What about the last one? Your try. Okay. So whenever we want to solve this kind of questions, we always think of drawing out the hidden H first to further identify the positions of the more positive reagent. So this H will be added to this side, this carbon, okay? Because we only focus on two carbon, which is this carbon and this carbon, right? So the H will be focused, will be moving to this, and then the Cl will be moving to this thing. So this will be your major product. And your minor product is not just a Cl like that. Because if you put a Cl like that, it means to say you have taken away one carbon. So you can't draw like that. So it must be like that. And a bond to the Cl. Okay, this is the minor product. All right.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.